Hello.
Good afternoon, Kapachan.
Afternoon, Let me get my OBS running. Yes. There's an update. Wait a second. The thing about using OBS on MacBook M1 is that it's not exactly supported. So if I update it, there's a chance it breaks a whole bunch of things. Nope, not this cable. Screen. This. Protector, full screen protector. Lock. Screen. Oh, there. Interrupt. Wait a second. That's it. Why can't I switch the screen? Okay, there. You can see my screen, right?
Yes, Kap.
Window. Second, let me resize this. The thing about Zoom that is it doesn't kind of remember the size that I resized last time. So you need to keep resizing this. So quick reminder, homework is still on Thursday, right? I don't remember. Right. Yeah, Thursday. So if you have question, homework 0 is very easy. If you're done with it, I recommend you start homework 1 like now. Homework 1 is much harder. Second. And I uploaded all the lecture notes, right? And all the lectures. If I forgot, keep reminding me, keep bugging me because I tend to forget. Homework 0 was easy. Yes, it's supposed to be easy. Yes, you can make a meme. I know what you were thinking about, now what? Yes, her homework 1 is much harder, but why do I have this little green thing over here? But whatever, you don't need to know the time nor the batteries. Does it show up? Okay, it shows up. The thing is, this is not, well, it is a warning and it's also a true statement that homework 1 is much, much, much harder than homework 0. So if you're done with homework 0, start it now. So you get a head start. Okay. Homework 0 requires not much imagination. Homework 1 requires a lot of imagination. So at least read it ASAP. Okay. So you know what to do. Okay. So what we're going to do today is more proof techniques. And if you have time, I'm going to play more card tricks as well. if I remember to do that, because you need the card trick for the homework, but we can do that on Thursday as well. More proof technique. Okay, so last time, what if you don't have imagination? You will, you will by the end of the course, or else you change your major. You don't see any handwritten lecture. It's under file. It's under file. It's under file, and there's a lecture handwritten something something, and then click the right terms, and then it should show up. Goodbye, everyone. Crazy. You still need to do discrete math, though. I think, but you do it with ICT or something. Okay, so let's do this. I'm gonna ask something really, really funny. Well, not funny, but something really, really stupid. How do you know I'm not dead yet? How do you know? This is not a philosophical question. Answer me something stupid. Very good, because I'm talking, right? Okay, so to prove I'm not dead. Okay, so theorem. I'm not dead. Right? Of course, you can get into the philosophical question that like, are we in a bottle like in the Matrix and so on? But let's not go there. Let's not go there. So theorem, I'm not dead. The proof is simple, right? So you say the following: assume that I'm dead. Assume I'm dead. I can't talk. Okay. But the fact that I can talk, but I'm talking, therefore I'm not dead. Right? So this is a contradiction. This is a technique. It's called contradiction. Okay. You assume the theorem is false, right? So this is what we do. Assume I'm dead. Sorry. Okay. And why is that play button? Wait a second. Let me get rid of all the things. Okay, where's the window? I need that space. So guys, hey, you. How do I hide you? Technology. Okay, good. Okay, so the idea here is, if you want to prove that I'm not dead yet, right? Then you assume the other way. You assume that the theorem is false. I mean, I'm dead already. But then that leads to the conclusion that I cannot talk, which contradicts what you know is true. Like I'm talking. Okay. Therefore, what you assume here cannot be true. Therefore, it's false, and therefore I'm not dead. Someone good? Right? Another example would be, how do you know there's no black hole in the center of Bangkok, right? Right? We know that if there is a black hole at the center of Bangkok, then everything is gone. But the fact that not everything is not gone, therefore there's no black hole. Okay, sounds good. Yeah, sounds good. So let's see how do we use this kind of things, right? How do we use this kind of thing? If you learn cosmology, there's something called microscopic black hole or something that it evaporates really quickly. So when they try to build what's that called, CERN, the CMS, the CERN, the LHC, you know that there's a really huge collider at the border of Switzerland and France, right? When they try to build it, one concern is because one physicist, they don't think before they talk to the public. They say that this machine could create a black hole, and you know what happened? People protest that, okay, don't build this, you're going to destroy the earth. It's actually, what he meant was a tiny microscopic black holes that evaporate really quickly, but the news say it creates black holes, so people come in and protest, don't build this, you're going to destroy everyone. Okay, so let's see how we're going to use this in some more mathy way. Okay, so last time there was a question, right? That there was someone, I don't know who, but asked, this number is not odd because it's even, but there's one thing we never proved, right? That there's no number that is not both odd and even. There is no number that is both odd and even. Okay, I'll try to improve my handwriting as I go. And some students said that I use most the color. I use most the highest number, the most number of color in my lecture note. Other people never change the pen color, so I'm gonna keep changing my pen color. So the proof, right? To prove that something doesn't exist, that's actually hard because you need to look at one way you can do it, right? You can go look at each number. Okay, 1 is 1, both odd and even. If not, you throw it away. It's 2, both odd and even, right? It's -5, both odd and even, then you throw it away if it's not, right? So if you see the way we need to prove this is kind of difficult because if you think about last time, right? We say that assume x is even, y is odd, then x times y is even, right? Then we know how to start. The fact that we can start is because we know something about what to start, right? We know something about x and we know something about y. But to say that there's no number that's both odd and even, there's no handle at the very beginning, right? There's no handle at the very beginning. But contradiction, right? Okay, the thing that I'm trying to teach now is called proof by contradiction. I forgot to say proof by contradiction. Okay. Okay. The thing is, sometimes when you assume that the theorem is false, you have a lot of handles on how to start. Okay, so let's do that. So let's say let's write this. Assume for the sake of contradiction that, okay, what do we assume though? What do we assume? If we assume that the theorem is false, what can we assume? What can we assume? Can someone tell me? No number. Let's say no integer to make our life a little bit easier. Let's integer. There's an integer that's both odd and even. And since Nawat said it, oh, let's call it W because if I say N, you're gonna get confused. Let's call it W for Nawat. Okay, let's say Nawat number W is both odd and even. In integer is both odd and even. Sounds good, right? Okay. So remember that symbol E, that's in. Okay. There is a number W in integer that's both odd and even. What do we know? What do we know? What do we know about W? For the fact that it's both odd and even, what do we know about W? It's in I. Yes, we know that fact. Do we know something better? Like the fact that it's both odd and even, 0 to infinite. No, actually, it's actually include the negative number as well, but that's good. But the fact that we know that it's both odd and even, what else do we know? What else do we know? What exactly does it mean for it to be both? Yes, right. So that means first, we know that XW is 2n for some, right? That thing is for some n in integer, right? Because it is even. Because it is even. Right? What else do we know? What else do we know? For the fact that it's odd, what do we know? What else do we know? Very good. Peter, good. What is W? Again, this is called Nawat's number. We assume that there is a number that is both odd and even, because we want to make the theorem false, right? If the theorem is false, there is a number, right? So let's call that number, at least one number. Let's call that number. Now what's number for W? That is an integer that's both odd and even. And for the fact that it is even, we know that W is 2n for some number n. And also, we know that W is 2n plus 1. Is it good? What do you think? What do you think? Because it's odd? How can I fix this? This is bad idea. This is totally bad idea. Good. Don't reuse the same symbol to mean different things, right? N and M may not be even the same number, right? Okay. Right, it may not be the same variable, so we do this. Okay, now what's the problem, right? Remember, we want to show that if there's a black hole, then the Bangkok is gone. But the fact that the Bangkok is not gone, then therefore there is no black hole. So the goal here is to find some contradiction. What's wrong with this? What's wrong with this? What's so tempting to do here? So tempting to do here. N and M cannot be the same. It may not be the same, not cannot be the same. Make them equal, right? Because we know. Okay, therefore, we know so far, this is by logic, right? By logic, that just equate them, that 2n is 2m plus 1. What's wrong with this? I don't see anything wrong with this, right? I don't see anything wrong with this. What's wrong with this? It won't end up being an integer. How do you know? Yes, eventually it won't end up being an integer. How do you know? How do you know? Can you make this thing a little bit more clear? Very good. So we divide by 2, the whole thing, right? So we say that n is m plus a half, right? So now you know, right? If n is an integer, then m won't be an integer. So that means if n is an integer, and that claim comes from here, then m can't be an integer. If this, wait. If let's do it the other way around, because I write this the other way around. If m, right? If m is an integer, you add a half to it. It's not integer anymore, right? Then n can be integer, but we assume that n were an integer, right? But we know that n must be integer. And integer, we have our contradiction, right? Therefore, let me use the color. But n must be an integer because of that. And we have our contradiction. Thus, there is no number that is both odd and even. Okay, and I don't have a place for my square. That one's clear though. The concept is kind of a bit confusing if you read it for the first time. But the gist here is the fact that it leads to some contradiction. In this case, it's the fact that n will not be an integer, but it has to be an integer. Right? One good? Any questions so far? Any questions so far? Any questions so far? We're gonna do something more complicated. Your brain is burning. Wait until the next one. Okay. Wait until the next one, right? We are giving a much better reasoning, right? We're giving the reasoning. This class is about reasoning. Okay. So let me recap real quick. So we want to show that there's no integer that's both odd and even. Okay, so we assume, so we assume for the sake of contradiction, right? We assume that the theorem is false, and we want at the end to see some contradiction. We assume the theorem is false, so that means we assume that there's a number which is now what number, right? That is integer, which is both odd and even. Okay, and for the fact that we know it's odd, then we know it's 2n plus 1 for some m and 2n plus 1 for some n, and both of them has to be an integer, right? N and m are integer. But when we equate them, we found out that if one is an integer, the other one cannot be an integer. Therefore, the theorem, the thing that we assume for the sake of contradiction cannot be true, which means the theorem is true. Sounds good? Right? Okay, let's do something a little bit more complicated. Any questions so far though? Any questions so far? If not, let's do something a little bit more complicated. Theorem. If A, B. So we prove by assuming that the opposite would lead to something that contradicts itself or contradicts the fact that we know is true. Okay. If A, B, and C are odd, so in this case, I'm going to do that big O. This is odd. I think when I typed it up, it's O and with some funny symbol. So, but if A, B, and C are odd number, then I claim the following, that ax squared plus bx plus c equals to 0 has no integer solution. Okay, so I claim the following. And again, this is when you read the question, you kind of know that, okay, contradiction will help us. But sometimes you can prove it in many ways, and whichever way is valid, then your TA gonna read it and grade it accordingly. So don't worry, someone's gonna read it. And there's multiple ways to give a good reasoning for the theorem, right? To give a proof to the theorem. Okay, it's not some fixed way to do it. Right. So you now see it's the same problem, right? We have no handle. Right. So one thing Peter suggests, so we can plug in every single x. Right. Plug in every single x and say that there's no solution, it doesn't equal to 0. Right. So if we need a handle, right? If we have a solution, that would be our handle. That's why something that looks like this. That we have no handle at the beginning, but if we were to assume that's true, then we're gonna have a handle at the very beginning, then we should do the contradiction proof, right? So let's do this. Let's change the color. Let's make it pastel. Pastel would be really hard to read. 2 seconds. Orange, good. So let us assume, for the sake of contradiction, that x is the solution. Ax squared plus bx plus c has the solution. Equals to 0 has a solution. Okay, let's call that xs. What should I call? Let's call that k. Let's call that k. Okay, okay, and quotient. Yeah, has a solution k, which is an integer as well. So that's good. We assume that it has a solution, and we call that solution k. Okay, for fixed a, b, and c, for some a, b, and c. What do we know? What do we know about k though? What do we know about k? What does it mean to be a solution? What does it mean to be a solution? K greater than 0? I don't really know. I don't really know. I know that it's an integer and it has to be a solution. What exactly does it mean to be a solution? What exactly does it mean to be a solution? Very good. When you plug it in to here, right? So that means we know to be a solution, what it means. Actually, let's do another color, pink. To be a solution, it means AK square plus BK plus C has to be 0. Okay, that's what we know. Okay, that's exactly what it means to be a solution. That means you plug in the left and it's equal to the right. Okay. Now, anyone has a good idea where to go next though? Where to go next? How to go from here to there next? Anyone? What are the possibilities for K? What are the possibilities for K? Any integer, right? What are the possibilities? Can we separate them into like some subgroup that we kind of know how to work with it? Positive and negative. That's not bad, but it's actually hard. Another group. Can you separate them into two groups that we know? You can't guarantee to do that, but we will try to show that there's no solution. Odd and even. Okay, so let's do what Alexei suggests. Can we combine K square and K? What do you mean? I don't know. I don't think so. Okay, let's see. So K has two choices, right? It has to be either odd or even, right? So case A, let's do case A. If K is odd, okay? And case B, if K is even. How about we plug in odd or even number? Okay, good, right? So we the goal here is we want to show that no matter what K is, no, if K is odd, we lead to something funny. If K is even, it's gonna lead to something funny. Okay, that's what we try to do. Right? No matter if K is odd or even, it's gonna lead to something funny, and then we have our contradiction. Okay, now how do we know? How do I know that K cannot be odd? I know the K cannot be odd. Can you tell me how? How do we know the K is not odd? So we know a couple things, right? We know that when we plug in K, that thing has to be true, otherwise it's not a solution. Okay, so let's try plug it in. Okay, so we know that this thing gonna happen. Okay, good. Who's that? Bomb suggest something looks good. Bomb suggests something that looks like, okay, let's check AK square plus BK plus C, right? We know that this thing has to be 0, right? So at least we know that at least the left-hand side, it has to be even number. That's good, right? At least the left-hand side, it has to be an even number. Otherwise, both sides cannot be equal, right? If K is odd, what do we know about AK square? What do we know? If K is odd, what do we know about AK square? It's always odd, right? Because A is odd, K is odd, so K square is odd, and AK square is odd. Therefore, this thing we know is an odd number. So that's good, right? What do you know about BK? We assume at the very beginning, right, that A, B, and C are odd, right? What do we know about BK? It must be odd, right? Because B is odd, right? B is odd, so it's like odd times odd. Yes, that's what we did last time, right? Odd times odd is odd. Okay, and C, well, by definition, this has to be odd, right? Okay, so we know that this thing is a sum of three odds number. Therefore, it is an odd number. Therefore, we know that it has to be equal to 0, but 0 is not odd number. So therefore, K cannot be a solution. K can't be a solution. Can we call it done here? That okay, if K is odd, then something is wrong. Can we call it done? Not really, right? Because we have another way. If K cannot be odd, you're gonna ask, okay, what if K is even? Maybe we have a solution. Okay, so that's like half done. But you know, half proof is like 0 proof. Half proof is 0 proof. Okay, so you still have one more question, right? What if K is even? What if K is even? Now, can someone tell me what's wrong with K is even? If K is even, what's wrong with it? What's wrong with the fact that K is even? What do we know? We need to check this, right? Are you sure? How do you know, Peter? How do you know that the solution will be even? A plus B plus C mod 2 is 0 is even? No. We are not talking about A plus B plus C, right? What we are interested in is this guy. AX squared plus BX plus C, right? So the thing that we want to check that is odd or even is AK squared plus BK plus C. Right, so just say, okay, Ajahn, because K is even, right? AK squared, this is even. BK, because it's even times odd, this is also even. Right, this is even times odd. And C is odd. So if we add the three together, what do we get? Even plus odd, what do we get? It has to be odd number, right? Therefore, K cannot be a solution as well. Which you can call it done because you have the contradiction, right? This is our contradiction here and there. Okay, 2. We say that K has to be a solution, but when K is a solution, then it has to be odd or even. It doesn't matter what it is, and it cannot be a solution. Therefore, we have a contradiction, right? Right. Therefore, the claim is false. Right. So what the thing that we claim, right? That is AX squared plus BX equal to 0 has a solution is false. Therefore, the theorem that says it has no integer solution is true. Everyone good? Right, everyone good? Okay, we can do another one. We can do another one. Any questions so far though about this guy? What do you mean by has no integer solution? It means no matter what kind of K. What kind of what do you mean by it has no integer solution? Yes, 0 is even, Peter. 0 is 2 times 0, right? Therefore it's even. Okay. Okay. What do you mean by it has no integer solution? It means that no matter what kind of X you plug in, both sides cannot be equal to 0. The left-hand side cannot be 0. Right? In which circumstance will this technique be useful? So here's the thing, Chris. There is no fixed method in proving. There's no fixed method in proving. If it doesn't work one way, you try another one, you try another one. There's no fixed method. But if you do enough proof, then you're gonna see that this kind of useful if you have no handle at the beginning, and if you assume that's false, then you have a handle. And by handle, I mean the following. I mean, you have something to work with. So in this case, you have K to work with. Right? You have K to work with, and then you do something about K, and then you show that, okay, it leads to something funny. Right. Okay. So if you try to show that something doesn't exist, yes, we could. Yes, we could. Anapat, yes, we could. Yes, we could. This proof can be written as a non-contradictory proof as well. Right? You can rearrange something. But I want to show this just to showcase, right? Okay, but yes, there are multiple ways to show this. Okay. Any more question though? Any more question? Then we're gonna get to a real thing. We're gonna get to a real thing. This one actually, I think, if Wikipedia is correct though, the history is this one gets someone killed. This one gets someone killed. Okay, so let's look at this. Okay, definition. A rational number, a number is rational if anyone know what a rational number is, right? Anyone knows? Can you give me a rational number? Anyone knows? No. Okay, so if a number x, let's put a number x is rational in real. Okay, let me in real. This is real. Is rational if and only if x is equal to p over q for some p and q in integer. Which means, so for example, 1.5 is rational because it's 3 over 2. And that's your P, that's your Q. Both of them are an integer. Right? Or something like 1.1111 and repeated 1 is 1 over 9, which is P in integer and Q in integer. Right, this is number 9. 9. So a number is rational if you can find P and Q. Then you can say that a number is rational. But Bohm suggests some number, square root 3. If you punch into the calculator, I don't know, 1.73 something. It's irrational, okay? So a number is irrational if, so let's do this. A number x in R is irrational if it's not rational, essentially, but if and only if x is not equal to p over q for all p and q in integer. So that means that doesn't exist. You cannot write it as a fraction. Okay, so essentially this is what it means. You cannot write it as a fraction. There's some other numbers like pi, 3.14, and some really long number. And e is also 2.7 and some really long number. Or maybe since you are you're going to see this number later. This thing about 1.6 and 1.5, I don't remember. Let's say 1.5 and then some really long number. Okay, but you get the idea. But to prove that these numbers are like a rational number is actually not easy. So I'm clear on what a rational and irrational number is, right? Any questions? Any question? We get to a definition. Okay, so definition means I give you the vocabulary. Can you explain it again? Yes, we say that a number is rational if you can write it as a fraction, an integer fraction, not just any fraction. Okay, right? So for example, 1.5, you can write it as a fraction like 3 halves, or a number that is easy as like, I don't know, 5. You can write as a fraction, it's like 5/1. What's the symbol for irrational? I don't remember. Rational, you use Q though. But irrational, I don't remember. But typically, if I don't know what to do, I made up symbol in class, right? What do you like, Tom? Not Q. let's call it irrational. What about in float? Is rational since we can write as a fraction. In computer, so if you say in and float in IEEE, in how it's stored on your computer is rational. Unless we do something funny about it. The way it's right at IEEE. So IEEE is do this right. You keep it as a binary. What's the inverted A? This is for all. This is their access. Or for some. You should know that by Thursday, by the way. Inverted A and inverted E. How about square root -1? Is it also rational? That's a good question. That's a good question. Except it doesn't fall to our definition at all, right? It's neither rational nor irrational because we only say that, okay, x has to be real, but I is a complex number, square root -1, right? Okay, so here is how you get yourself killed in a cool way in like, I don't know, 2000 years ago, maybe. I don't know. Don't quote me on the number. This is a theorem. Square root 2 is irrational. Okay. You may ask, how does this get someone killed? Like, in Thailand, if you say the wrong thing, you get yourself killed. That's the same thing in Socrates or Aristotle way. in the old day, I think it dates back to Aristotle, this question. They believe that every number is rational and they believe it as a religion, right? They believe it as a religion. Is Thursday going to be a holiday now? I'm trying to be careful though. You know what? So square root 2 is irrational because they believe, like, religiously, that every number is rational. Now someone give you a proof that, okay, what you believe is not true. Aristotle guy, he's a good guy. He is a very good philosopher, but he's like the worst scientist, the worst kind of scientist. Because he actually pushed back the science for a couple hundred years for the fact that he believes that the thing returns to Earth because it has more Earth element and so on. And that Galileo needs to test his theory. That he said that the steel ball wants to go to the Earth faster than the tennis ball, and that's not true. Gödel completeness theorem. Actually, because it's probably 1900 something, right? Gödel's incomplete theorem, so people kill each other less often than. Okay. But for everyone who wonder, that's a good one. Veritasium did a video on that, so you should watch it on Gödel's incompleteness theorem. Not that you understand it though. I have a really hard time understanding it, but it's cool regardless. Okay, so now we want to show that square root 2 is irrational. Okay, so that means we want to show that. So we need to understand two things, right? The first thing is, what is a square root 2? Can someone tell me what is a square root 2? What is a square root 2? We need to understand square root 2 and we need to understand the irrational, right? Very good. Now what's it? Okay, square root 2. Square root 2. Square root 2 is a number, right? Square root 2 is a number that when you square it, you get 2. And positive as well. There's a minus square root 2. But let's forget about all the details, right? By definition, the definition of square root 2 is a number that when you square, you get 2. Okay, now we know. And we want to test the property of x, right? We want to test the property of x that no matter how you do it, right? No matter how you do it, what's it called? No matter how you do it, you cannot write x as p over q. right? There doesn't exist P and Q, or the other way to say this is, so this thing is there exists, right? If I do this, is there doesn't exist P and Q in integer such that X is equal to P of Q, right? This is what it means to be irrational. So this is what we want to show. We want to show that the number that when you square it, you get 2 cannot be written as a fraction of integers. Okay, anyone want to get yourself Q in 2000 years ago? How do we start? Okay, let's do something very dangerous 2000 years ago. Can you explain that again? Yes, of course. Yes, so in this class, if I say something that doesn't sound right, pause me and let me explain that again, because I want to go together with you guys. So we try to understand two things. That we try to understand two things. We try to understand what is a square root 2. We now know that a square root 2 is a number x. So that x is essentially square root 2. But I'm not going to write it as a square root 2. That number, when you square it, it gives you a 2. Right? That's what the definition of square root 2. Okay? And that there's a technical difficulty that x has to be greater than 0 and so on. And also, we say that that number, that special number, that when you square it to get 2, you cannot write it as an integer fraction, because that's what we want to try to show. The square root 2 is irrational. That's good, right? Any questions? We understand what we try to do, right? We try to show that the number that you square cannot be written as a fraction of integers. Okay, so anyone, how do we get ourselves Q in 2000 years ago? Replace X with P and Q. Okay, good. So let me explain that. So we're gonna assume, right? So to show that you cannot find something is hard, like what we did before, to show that you cannot find something is hard. So let's assume that's false. Let's assume. Okay. Let us this color, I use it too much. Let's change it. Or is it green? Okay, good. Yeah, let's make it red because this thing gets someone killed. So let's assume, for the sake of contradiction, that square root 2 is rational. Okay, meaning that, right? We know, meaning that square root 2 is P over Q for some P and Q in integer. That's good. The one with me so far, right? Because the fact to show that you cannot find it, that's hard because you don't have anything to begin with. Now you assume that it's false, therefore it's rational. Then we have something to begin with, like P and Q. Okay. Is there a shorter way to? Okay, let's make that up together, and then I'm gonna tell the grader. Assume for the sake of contradiction. Okay, this is our official abbreviation from now. Unofficial. That's good. That saves you a lot of writing. Assume for the sake of contradiction that square root 2 is rational. Square root 2 is P of Q. By unofficial, if you take a lot of class with me, they will figure out. Will they understand it? Most likely not, but they'll figure out in. Nah, not for the sake of contradiction. So if you take a lot of class with me, you're gonna see one trend. I forgot about names. Then I'm gonna make up names in class, and it's your job to go to Wikipedia and figure it out. And figure it out what's the actual name of the thing is. You can complain to OAA though that Ajahn doesn't know names. Okay, do whichever one, and then you tell your TA when he asks as well. Okay, I'm going to assume further though. I'm going to assume further. This will make your life a lot easier. So for example, if I write a fraction like this, you're going to scream, right? When you were a kid. If I write a fraction like 4/6, what's so tempting to do? When I write something like this? Can you read? You, so tempting to do like, oh, come on, Ajahn, there's a factor of 2 on the top and at the bottom, right? We should cancel it out. Okay, you simplify it. You can say, okay, it has to be 2/3. Okay, so far so good. So you see, I'm gonna assume further that both of them cannot be even at the same time, right? Because if they're even at the same time, then I'm gonna just keep cancel the 2 until there's no 2 to cancel. That's good, right? And both P and Q are not both even. Okay, so that's good. So we can say that if it is a fraction and if it has a factor of 2, I'm gonna keep canceling it until at least one of them is odd, right? At least one of them is odd, so they're not both even, because if they are both even, then I can keep canceling out the 2 until I get one odd, and then I get at least one odd and one even. So for example, you can have 6/10, right? This thing is 3/5, right? They are not both even, right? They could be both odd. At least they're not both even. Right, if one is odd and one is even, then I'm good. I say that, okay, direct is a P and Q. If there were a fraction, I should be able to find P and Q such that they are not both even. Okay, sounds good, right? That's what we assume. And this will become a key later on. Okay, what do we do next? Anyone? What do we do next? We know that square root 2 is P over Q, but we try to get it to lead to some contradiction, right? To end, that's too hard. When this should be intrinsic to you. When you see an equation that has a square root, get rid of it, right? How do we get rid of the square root? Square it, good. But before I square it, I'm just gonna call it x for now. Okay. Before I square it, so I'm gonna say that, okay, we know that xq is p, right? That we know so far. We know that xq is p. Okay, but essentially it's square root 2 q is p, and we try to get rid of, actually let me move this a little bit. I need a lot of space. Okay, so let's do this. We don't know what to do next, so let's square both sides, right? When you square both sides, you're gonna get 2q squared is p squared. Okay, 2q squared is p squared. You may say, Ajahn, you're not going anywhere, right? You just do random things. No. But if you notice carefully, what do we know about p? What do we know about p? Can someone tell me? And why? P is an integer? Yes, we know p is an integer. Do we know something more? Do you know something more about p? Can be even or odd? Are you sure? Are you sure? Odd cannot be 0, it's odd. How do you know? No, what? How do you know p is odd? Because q is even. We never say the q is even, right? I don't know q is even. Must be positive. Not really. What do we know about p? What do we know about p? Either odd or even. Justin, oh, I'm waiting for your answer. You said, oh. What do you notice? What do you know about p and why is it? Q has to, no, two. Q has to multiplying it. That no. The fact that 2 is in front of Q doesn't mean that Q is even though. No. So for example, I can multiply 2 and 3. I can multiply 2 and 3, but that doesn't make 3 even, right? Okay. Not bad. But what do we know about P? Okay, let me ask you even simpler question. What do we know about P square? What do we know about P square? Double Q square. Something even simpler. You said the right thing because you just copied the thing on the left. What do we know about P square? Yes, positive. Now that reminds me that Apple Pen song PXP. Wait, that P square. What do you know about P square? What do we know about P square? What do you know about P square? Risky is close. What do we know about P square? Is it even or odd? Even or odd? Even or odd? Even or odd? Has to be even, right? Because P square is 2 times something. It says over here that P square is 2 times something. Right? That means P square has to be even. Right? Let me move this thing. Okay, our reasoning is here. Therefore, P square is even. What do you know about P? If P square is even. What do you know about P? If P square is even, what do you know about P? P has to be even, right? Because if you have an odd number, you square it. It's not going to be even, right? So that means P has to be even. That sounds good, everyone? Right? Because if P is odd, you cannot do it, right? If P square is even, right? If P square is even, then P has to be even. Otherwise, when you square it, you're not going to get even, right? Like 3 square, you're not going to get even number. Sounds good? Any questions so far though? Let me pause here a little bit. It is deep. not that deep though, but if you see it, you see it. If you don't, then you're gonna get lost for the rest of the class. Right. You just said it, Risky. 2q squared is 2n. That n is q squared. That n is your q squared, right? Because p is 2 times q squared. And that q squared is a number, an integer, right? Therefore, p is even. Okay, that's clear, right? Any more question, right? P is even. Now we know P is even. How does it help? Do we have our contradiction yet? Do we have our contradiction yet? In this case, what? No, not really, right? We just say that they cannot be both even. One of them is even. That's good, right? That's good. As long as they are not both even, then we are good, right? But if P is even, what do we know about P? Divisible by 2. Okay. P. Oh no, Peter, you're trolling. If P is even, P is not odd. We just proved it like 30 minutes ago. P is even. What do you know? P is 2n. Okay. Oh, you mean Q is odd? Let's not do that yet. Okay, let's not do that. Okay, that means P is 2n. Everyone is clear, right? P is even. Okay, that means P is 2n. For some n in integer as well. So let me cheat because I ran out of space. I want to put everything in one sheet. Okay, P is even. That means P is 2n. Okay, I'm gonna do something extremely dumb. Extremely dumb, which means you're gonna put this back in there and see what you got. Okay, we're gonna put that back in there. Okay, put that back in there. So we have 2q squared is 4n squared, right? And put that back in there, and this is what I get. Sounds good? What's so tempting to do? Divide 2, right? Get rid of 2 on both sides. So that means we know that q square is 2n square. Where does 4n square come from? So p is 2n, right? 2n square is 4n square. Okay. Mind blowing, right? What do we know about q? Can you see it? Q square is even, right? Therefore, Q is even by the same reason. Okay, so we have these two. We learned two things, right? That if square root 2 is P over Q, then P and Q has to be both even. Is someone with me so far though? Any questions so far though? We're gonna get to our punchline, right? Right. From here, you know that Q square is even, therefore Q is even. Sounds good. So far, so good. Right. So any questions so far? Or any questions so far? Any questions so far? No question. Okay, good. So which means now we know, right? Which contradicts with that statement. Okay, let me get rid of this trivial thing. Okay. Okay. The fact that both P and Q are even contradicts with our earlier statement. Thus, square root 2 is irrational. Okay, you can draw like, I don't know, a skull and then a cross because someone died for it. You want Thursday to be a holiday or not? Imagine getting killed for being too smart. That's exactly what happened in Thailand. The note will be uploaded. Yes. The note will be uploaded. If it doesn't go up in like 2 days or something, then scream at me and then I'll upload it. Any questions so far though for this? Like, you know, it's kind of cool, but I want to point out one thing. The fact that you understand a proof in the class doesn't help. That's one thing. The class like entertainment. Okay. The fact that you understand a proof in class doesn't really help. What I want you to have for the skill at the end is how to come up with proof. That's why I try to brainstorm it with you guys. So you know how to come up with proof. You essentially it's trial and error. Okay. Essentially it's trial and error until you know, okay, the right idea to get to the proof. Then you write another proof. Then you collect every thought and put it there. Why can't P and Q be even? Because if they are both even, I'm gonna keep canceling out until P and Q are not both even. Right? So for example, if I have what 8 over 12, right? Then I'm gonna keep canceling out the 2. Then I'm gonna get 4 and 6. Then I'm gonna get 2 over 3. Right? By keep canceling out, I guarantee that I will at least get one odd number. Does that sound good, Anapat? How do we get proof skill? Good question, Peter. That's why you have homework. That's why you get homework. And like I said, I'm not too serious about collaboration, but let me emphasize the fact that I want you to learn how to come up with proof. So that means if you see a spoiler, you're not going to learn how to come up with proof. So the spoiler will hurt you a lot. So you can help your friend, but don't give them a spoiler because it will hurt your friend. I want you to have the skill of how to come up with a good reason. It's actually it's not a very specific skill to math. It's actually a generic skill. How to convince yourself that something is true, like without any more question. Okay. Any questions now? You need a lot of brain power in the homework. So do it. Start now. So any question? If not, we're gonna take 10 minutes break because someone's gonna want the break, right? So let's take a 10 minutes break. And where's my mouse? So we're gonna come back at wrong. Come back at 3:40. What time is it now? 3:15. 3:15 p.m. 2 seconds. Let me find the window that I can chat. 15:15. Okay, that's good. Okay. Can take 10 minutes break. Is that a food or a dog or a cat? It's a cat, so cute. Okay, guys, you are allowed cat in the exam. This is official. You are allowed cat in the exam for moral support. If I allow dogs, I think that's he's gonna distract you. Like you're allowed to have cats in the exam. You can ask the same permission with Ajahn Kanak. He loves cat. Okay, Thanatat, I forgot to click publish. I uploaded it, but I forgot to click publish. But let me, in the meantime, upload another one. Lecture 2. Share. No, not move to trash. No, don't go there. There are 2 items in there, but can't see. I just changed the permission so that you can see it. There is an item called handwritten lecture notes. Yes, I just put it there because I forgot to allow you to see it. Replace lecture 2, and let me just upload it now. Discrete math and files. There. If you want to say that no one does X, not the cardinality of the set of people doing X. Yes, that's the same statement. Yes, that's the same statement. But it's easier for you to say no one does X. So this is about the homework, right? So if you can do this, you can do this. Well, I told you not to use that not, right? You can do that. Yes. Or you can do this, like what we just did today, right? There doesn't exist X, such that PX. That works too. About at least one. Yes, at least one there exists X, PX. Okay, your cat is gone, so The official symbol for such that is actually that line, that vertical line. But I typically just spell out such that. This is official symbol for such that. But I recommend you just spell it out, such that. Spelling it out is much easier to read. Yes, ST works. Can you use dot to separate quantifier from dot position? No, dot. Don't use the dot. You just say s dot t dot. That works too. I type in LaTeX for Homework Zero. That's good for you. There's a for those of you who don't know, the way back then it's so hard to install LaTeX on your computer because I kid you not, it's like 3 gigabytes if I remember correctly. It's like 3 or maybe more now. But for now, you do overleaf.com. Much make yourself much easier. No need to install. Okay. So if you want, you still have time. Overleaf.com. That's a bit of learning curve, but do it while the homework is still easy. Why overleaf? Overleaf.com. Yes. Wait. Okay, let me spell it out. Over. Yes. Yeah, some people love Notion as well. Some people do this Markdown. Also has limited LaTeX support. Some people do Markdown. Markdown, you can do LaTeX in like the $sign. And then you can do slash, which way? For all X. You can do Markdown. Overleaf is probably the easiest one. Or Notion works too. Okay, let's get back to our thing. So the next thing that I'm gonna talk about is something actually related to contradiction, but sometimes you phrase it in such a way that it's much easier to deal with. So for example, if I ask you, if I claim the following that it's not raining, at least where I live, what would you do? What would you do? It did not rain 5 minutes ago. Let's say it didn't rain 5 minutes ago. Let's say it didn't. What would you do? What would you do? If I claim it did not rain, ask Google. Actually, there's a website called isitraining.com. You can go to it now. It actually checks your location and everything. But this is not about that. Let's say you're like normal people. What would you do? What would you do? You look outside window, right? You would look outside window and see, okay, if the street is wet or not, right? You look outside window. You do it without knowing that you're doing this outside window. Okay. If the what's that called? The street, the pathway, the floor is wet or not. right? And then, let me just write. Yes, you look at the floor, right? And then you imply from the floor, right? You imply from the floor the following, that the floor is wet. The floor is wet. Oh, wait. You imply the following: dry floor means no rain. Okay, right? Then you use the following flag that, okay, the street is dry, therefore it probably didn't rain. But think about this. This kind of reasoning is funny because it's like revert in time and such as well, right? How do you know? Let me ask you a really simple question. How do you know that the fact that the street is dry, it means that there was no rain 5 minutes ago? How do you know? Can you tell me why? How did you know the following? That the dry floor actually implies there's no rain. How did you know? How did you know? Right, Noah said something close. The fact that you know this is because you know if there's a rain, then the floor is wet. Right? This is like physics. Right? Because you know if the floor, because if there's a rain, the floor is wet. That's physics, right? From that, you conclude that, okay, dry floor means no rain. Okay, so Pascal, you can see the logic, right? That these two statements are actually equivalent. And let me put it in logical symbols so you see it more clearly. So dry floor, let mean rain, let's call it P and Q. Oops, and Q, right? P implies Q, right? Over here, P implies Q. But what you use sometimes is not Q, right? Floor is wet, that means floor is not dry, implies not P. Okay. So the two statements are equivalent. Yeah, the two statements are equivalent and they are contrapositive of each other. Okay. So you can check the truth table as well, but we're not going to do it. But you convinced, right, that if sometime, if you can prove this, then you can have this for free, or the other way around, right? Sometimes when you do the contrapositive of the statement, then your life is much easier when you try to prove it. Okay, so instead of proving this, you can prove this instead. Are we good? Any questions so far? Or any questions so far? It looks obvious, right? It looks obvious, and until you use it. Okay. Sometimes it's easier to prove the contrapositive of the statement. It's the real life. Yes, this is the real life use of truth table. Actually, your computer uses a truth table. Okay. So think about truth table of the way to organize your idea. It's not exactly the fact that is useful, but the techniques of how to organize your ideas to eventually solve your problem. That's very important. Okay. So for example, I'm not going to ask you in the exam, is square root 2 rational or rational? No, that's not what I'm going to ask. What I'm going to ask is how you would show it, right? Okay. So let's do this. Contrapositive. Yes. Oops. I forgot the A. Okay, I see the bit. Contrapositive. This is called the contrapositive of the statement. Okay. So you do the following. Let me point out as well. A lot of people do it wrong. Not only that you negate each side, you switch them as well. So let's do this. It's negate and switch. Okay. Notice how Q come up there. Okay, so let's do something fun. Okay. So let me give you something like this. Theorem. 7x plus 9 is odd. Then x is odd. Let's put if over here. If 7x plus 9 is odd, then x is odd. Any good idea? Any good idea? How do we prove this? Can you use 3 lines equal? Yes, you can use 3 lines equal, or you can use this. They are okay. Any good idea? Any good idea for the proof? Remember, I'm not assuming that x is odd, right? I'm assuming that 7x plus 9 is odd. Okay, not the other way around. How do we begin though? How do we begin? I'm pretty sure by now you know how to prove this. We're gonna do it 2 ways. Plus 9. Let me check my handwriting. 7x plus 9. Okay. So I'm gonna get that grid, but not now. So let's do this. Let's do a direct proof. This is called direct proof. Okay. The direct proof would be, we know that 7x plus 9 is odd, right? So 7x plus 9 is 2n plus 1 for some n in integer. That's good. And then you go, right? Your goal is to show that, okay, x is 2 times some number plus 1. That's your goal, right? By direct proof, this is what you want to do. Can you help me? What do you do? What do you do? What do you do? What would you do? Okay, from here, what would you do? What's so tempting to do? I know you're going to say something, say that thing, make up some variable. What variable, right? Right, eventually we're going to. So think about this. We do not assume that x is odd, right? We assume that 7x plus 9 is odd. That's where we have to start. Okay, right? There's a difference. And then you're going to see why contrapositive is useful. So I suggest, okay, done, divide by 7. Doesn't help, right? Think about this. There's no divide by 7 at the end. Can you do something even more stupid than this? Okay, anyone? Give me something even more stupid than this, right? Divide by 7, that's a terrible idea. -1 both sides. Okay, at least let me simplify 9 run for you. 7x is 2n minus what? Actually, I want to. I rushed. That's why the theorem is not even true. Wait, 2 seconds. Let me fix it. Let me fix it. Sorry. Okay. Okay, I meant to say the following. That's why the theorem is not even true. Okay, I meant to say the following. 7x plus 9 is even, then x is odd. Okay, sorry about that. But the idea stays, right? The idea stays that divide by 7 is a terrible idea. So let me move everything there. Divide by 7 is a terrible idea. In the exam, the first thing you try is to pick some random number and plug it in. There's a chance that I made a typo. Okay, now, what do we do? Remember, our goal is the same. Our goal is to do this. Any good idea though? Divide by 7, not work. What should we do? What should we do? What should we do? Multiply. But the left-hand side, I want just x, right? I want the left-hand side with that x. Give me a really terrible idea, but it works. To make the left-hand side only has x. What do we do? To make sure that the left-hand side is only x. And I can tell you, it's not divide by 7. No, because if you divide by 7, right, what's going to happen is that then you're going to need to figure out, okay, Ajahn, what is this? Divide by 7. Right, Justin said, okay, Ajahn, I have a good idea. How about I subtract 6x from both sides? At least the left-hand side, at least the left-hand side is x, right? Okay. Okay, right? 2n minus 6x minus 9. Did you see what we are doing? It looks terrible, right? But actually it's the right idea. Is x 2 times something plus 1? Is x time 2 times something plus 1? Can you tell me? Yes, right? It's 2 times n minus 3x minus 5 plus 1. Therefore, x is odd. Right? Are we good? Are we good? Are we good? This is a direct proof. And you're going to see the problem, right? The problem here is that the starting point, the handle that we have at the start is like, what the hell is it? How should I work with this, right? And then you need to do some magical trick like Justin trick. Right, it sounds simple, right? But to come up with this, because the handle that you start with is so difficult. But let's compare it. Actually, what time is it? Okay, we're still good. Let's compare it. What if you do the contrapositive? What's going to happen, right? Let's compare that when you do the contrapositive. This is your P. This is your P. And this is your Q. I use green because your life is going to be a lot easier. Okay, so we will try to show that P implies Q, but we know that the contrapositive of the statement is what? The contrapositive is what? Can you tell me what is the contrapositive of the statement? Right? Contrapositive of the statement, we learned that we need to negate both of them and switch them, right? So it's not Q implies not P. Right. So can you spell it out? What exactly is not Q? Q is X is odd. What is not Q? X is even. If X is even, then what? 7x plus 9 is odd. Very good. Right? Then all we need to do is prove this. Right? Is prove this. Which is much easier because you know that, oh, since x is even, right? X is 2n. And then you want to check what is this? Then you just say 7 of x is 2n, not n. 7 times 2n plus 9 is, well, by definition, it's like 2 times 7n plus 9. Well, that's 5 minus 1 or something like that. Right? Therefore, it's odd. And then you're done. Or you can say that, okay, 7 times x is even, this thing is even, that works too, right? 7x plus 9, this thing is even, and this thing is odd, even plus odd, we know by now it's odd, and then you're done. I want you to see that the fact that it become much easier now is because this guy, right? The thing we assume is much simpler, is much easier to work with. Does that sound good? Right? This is one of the technique. If you try contrapositive and it work out nicely, then do that. If you can do direct proof, do direct proof. Doesn't matter how you do it. Any questions so far though, for these two examples, right? For these two examples. Any questions? You want to show that 7x plus 9 is odd, right? So you have many choices to do. So for example, you can do, since x is even, 7x is even, plus 9, 9 is odd, therefore the sum is odd, and then your theorem ends there. Right? That would be the easiest one. Right, Peter? Does that sound good? This is 9, not A. Wait, let me fix it. Does that sound good? So sometimes the contrapositive statement gonna make your life a lot easier because you can switch the handle at the end. Okay. So let's do another example, which is closely related, but you're gonna appreciate it. You're gonna appreciate it. So theorem, if, let me make sure I did not screw up. I have another screen. Is even, then X is odd. Okay, this is sort of the same thing. I think I want to get through. Okay. That's good. What do we do? What do we do? Right? If we try to do direct proof, this handle is even worse than last time, right? There is no just-in trick this time, right? There's no just-in trick for this time, much easier. Right. So it's much easier if we switch the two statement, right? Negate them and switch the two statement. Not don't just switch them, negate them too. So the proof much easier by contrapositive, right? Of the theorem is if X is even, right? This is your not Q. This is your Q. This is your P. Then X squared minus 6X plus 5 is odd. This is your not P, right? Right, then you can do the proof quite easily, right? X squared minus 6X plus 5, you know that X is even, so this thing is even. This thing is also even, and this thing is odd, therefore this thing is odd. That's the theorem is true. Oh, this is star. The star is M, right? Some people use star for M, the asterisk. Because they don't have latex. Because they don't have latex, they use asterisk instead of M. Is that one good? Is that one good? I show you that the contrapositive is actually quite useful to make your life a lot easier. Yeah. Okay, I'm gonna get to that next time. Then I'll change my example because I forgot to teach you one thing. Well, not forgot, but we ran out of time. Any questions about this? Any question about this? This is an example of how you use contrapositive. Sometimes it makes your life a lot easier. Yeah. So let's. If it makes your life much harder, don't do it. Don't do it. So let's consider this. This is a famous theorem. A famous theorem. So let's consider if there are 6 people in the room. There are 6 people in the room. Let's name them as well. A, B, C, D, E, and F. If there are 6 people in the room, okay, some of them gonna know each other, some of them not gonna know each other. Okay, so let me do the link. Okay, let's say, let me put someone, I don't know. Okay, maybe here as well, and maybe there as well. So I claim the following. I claim the following. A group of 6 people. Group, not group. Group of 6 people. I can find one of the following. Okay, I can find one of the following. 3 people who doesn't know each other at all. I call this a group of stranger. Okay, and also I claim that there are 3 people, or let's see, I can find one, or people who all know each other. And I say this is a club. Okay. So from the picture, can you find me one of them? 3 people who know each other, or 3 people who doesn't know each other? A, D, E is know each other, right? Because A, D, and E, they know each other. So far so good. So let's get rid of that. Let's get rid of that. Let's make sure they don't know each other. Okay. So actually, I think I went too fast. So A, D, and E doesn't know each other. Wait, A, D, and E know each other, right? So I want to make sure that that doesn't happen. Okay, let's try to find that. Okay, and then Saran also suggests, okay, Ajahn, now A, B, C doesn't know each other. Okay, let me make sure that C and B know each other. Yeah, I'm trying to find a counter example for this. Okay, or you can say that, okay, Ajahn, D, E, F now doesn't know each other. Okay, let me fix this by doing this. Now, can you find me a group or a club? 3 people who don't know each other? Q, who's Q? Q hat, who's Q hat? ADC. Oh my God, and now I know where you're getting it from. ASDF. Right? So there is D, C, and A. What about it? They know each other, right? A knows D. Right? So for example, this one, you have the 3 people who know each other really well, like B, C, and F, right? They know each other. Right? B, C, and F, they know each other. And if you try to get rid of one, then you have another problem, right? You have another problem over here, which is these people, they know each other now. Right? So I want you to see that no matter what, right? No matter what you try to do, you're gonna end up with either one of the case. Yeah, you're gonna end up with either one of the case. Everyone convinced? Is everyone convinced? Is everyone convinced? Okay, so let's look at the proof. F and D don't know each other. Yes, but I need 3 people. Who else? F, D, and B, right? They know each other. Well, what about it? Is this assuming everyone know at least 2 people? Not really. You can have this guy. So for example, if F does this, that works too, right? Then you have, then what do you have? Then you have A, F, and C who do not know each other, right? A, F, and C who do not know each other at all. So they are a group of 3 strangers. So that's good, right? I claim the following, that you can always do this, and we want to prove it. But if you think about this, Ajahn, that's easy. I just draw every single graph. Some people do that though. That's called 4-color theorem. You can read about it. But no, if you try to list all this is like, I think I count one time, it's like 10 to the 8. How many graphs are there? That's a lot. I don't remember the number, but some big number, some really big number. So enumerating them is not feasible. Okay? It's not feasible. So if we try to prove this, okay, let me help you. This thing is not obvious. Let me help you. Okay, so let's look at this guy A. Let's make them into 2 cases. Let's make them into two cases. So case A, let me put in A, B, C, oops, C, D, E, F. Okay, case A, which is A knows at least 3 people. Okay, before we get into the detail, let me make sure you understand this. Case B, if A is know at least 3 people, what is case B? The what's that called? The complement of A. What's it called? So if A knows 3 people, so that's that. What is the complement of all these cases? Three people do not know A. Yes, that those two statements are exactly the same thing, right? So what Justin said and what Saran said are exactly the same thing. So if A know less than 3 people, like strictly less than 3 people, right? So at least we know that there are 3 people who do not know A, right? If A knows strictly less than 3 people, then at least 3 people doesn't know A. Okay, we're going to show this in 2 cases. We're going to show this in 2 cases. Okay, now let's start with the top one. Let's start with case A. Okay, we have 6 people and we know that A knows at least 3 people. So let's draw this without loss of generality. So let's say that the 3 people who know A are B, C, and D. It doesn't really matter, right? Who I call A, B, C, and D. So far so good. So far so good. There's an E and F, which he may or may not know A, which I don't care. That's good, right? But I know at least 3 people, and I'm gonna renaming them such that the 3 people who knows A are B, C, and D. Okay, are B, C, and D. Okay, so if no A knows at least 3 people, okay, then anyone know how to go next? How to go next? If okay, now we simplify the problem, right? We have some handle. We make the case, so we have some handle that A is no B, C, and D. Then what do we do? What do we do? If it looks like this, let's say if it looks like this. If it looks like this, such that B, C, and D doesn't know each other, what do you have? According to our condition, right? We find the following. We find either a group of 3 strangers or a club of 3 people. Very good. So if B, C, and D doesn't know each other like this one, then B, C, and D are a group of strangers, right? Okay. If, then we have if B, C, D do not know each other, then by definition, right, B, C, and D are strangers. Okay, so far so good. So what is the complement of this case? What is the complement of this case? What is the complement of this case? So B, C, and D do not know each other. What's the complement of this case? What's the complement? Right, then B, C, and D, at least one of them know each other, right? So at least one of them know each other. It doesn't matter who know each other, right? B could know C, or they could both know them. So they could be like tight link, or they could be like one, but we know no matter what, they're going to be at least one pair know each other, right? At least one pair among B, C, and D know each other. Okay, at least one pair know each other. That means here, what do we have? What do we have? We do not have a group of strangers anymore, right? Because at least one B, C, and D know each other. What do we have in this case? A club of people, right? Which is, so that pair with an A are a club of people, right? Okay, from a club of people. Sounds good, right? Then case B, I say that, okay, there's an A and at least 3 people doesn't know A, right? At least 3 people doesn't know A. Okay, let me make sure that all these know each other. Okay, so case B looks very similar. Sorry about going over time. Case B looks very similar because if there are two cases that you need to consider again, this is like B1 and B2. Okay, if B, C, and D, right? B, C, and D all know each other. Then we have a club of B, C, and D, right? That's by definition. Okay, so the complement, I think, is clear now that the complement of the top case is the fact that at least one of them do not know each other. At least one pair among B, C, D do not all know each other. Okay, so that means this thing is gone, right? So at least let's be general, without loss of generality, let's call that B and D. What do we have in this case? What do we have? What do we have? 3 strangers, right? Very good. The pair that do not know each other, like B and D, do not know each other, plus A are now a group of strangers. A doesn't know anyone and B doesn't know D. A doesn't know at least 3 people. E and F could know A, but I don't care. Right? E and F could know A, but I don't care. Okay. Does that sound good? So this now completes the proof because we cover every single case, right? We cover every single case that's possible. Then it's guaranteed that we should be able to find either a group of strangers or a club of 3 people. Okay. Any questions so far though? Any questions so far? Any questions so far? Then we are done because we separate things into cases. Sometimes you need to separate things into 2 cases, like 2 times. Okay. I recommend this. This is an example that when you do this, consider the easy case first, and then you're gonna fill the rest later. What's the purpose of this question? Just to show this proof by case, just to show an example of proof by case because we have some time left. And this thing actually is quite important in computer graphics to triangulate things and to find that things exist and not exist and so on. Okay, but don't worry if you don't know how to prove this, but I want to show you the techniques that, okay, you can do proof by case. You can do proof by case, and that's an example of how to do reasoning. Okay, any questions though? Since we ran over time, sorry about that. And the homework due Thursday though. Yes, homework due Thursday, sorry about that. Okay, watch it again. I'll upload this once it's finished rendering. Yes, you can resubmit as many times as you like. Okay. See you, everyone. Numerical is supposed to do tomorrow, but let's add one day. It's hard, right? No one asked, but that implies it's really hard. Do it, do it, do it. You're gonna learn a lot in the homework. Okay, bye everyone.